Hello everyone. In this video, let's discuss about the Opamp with RC. Previously, we have discussed the same circuit, but in this circuit, I have introduced some practical concepts. In practical concepts here, uh, output of the op-amp can go till plus vset and minus vset only. Okay, so in previous video, if I don't keep plus vset and minus vset, if I analyze the same circuit at t is equal to 0 seconds, input is going from 0 to v volt. So because this is a negative feedback system, because the voltage v voltage is applying, so this voltage is 0 volt, this voltage is 0 volt, because this is a negative feedback system. So that this will look like voltage connected across a capacitor, so that impulse current will flow through this capacitor, and the same impulse current will flow through resistor. Output will be impulse minus delta of t into r. So this is the output voltage, but here output voltage of the op amp cannot go to minus vset minus delta of t, because this is impulse, it can go till minus vset. So in this case, how this will behave, let's analyze. Okay, till t is equal to 0 seconds. Okay, till t is equal to 0 seconds, I can say that vc equal to 0, and the same way ic is also 0, v out is also 0 volt. Okay, so then if I apply at t is equal to 0 second, what's happening is suddenly there is a voltage changing from 0 to v volt. Okay, at 0 to v, because of this 0 to v volt, so uh, this this capacitor, if there is a 0 volt here and 0 volt here, this demands a delta impulse current, but capacitor the output of the op amp cannot swing to minus delta of t into r, so that this op amp will come out of the negative feedback system, then it will act as a simple op amp. So there won't be any negative feedback. So at this condition, if I redraw the circuit, there is a capacitor here, and this is a b minus terminal, and there is a resistor, and this is a v out. Okay, this is a resistor and this is a capacitor, this is v in. Okay, so this is 0 volt and this is v volt. So here v out, so it will go to minus v set, because it tries to make this op amp to negative feedback system. This op amp, what it will do is, it tries to swing max voltage, negative voltage minus v set, and stays there. Then it will, because it is hitting the negative rail, it will come out of the negative feedback loop. So because of that one, here we should consider minus v set. Everything is happening. So while this is going to minus v set, everything is happening at t is equal to 0 instant itself, the transition point itself. So now we can say that this is simple RC circuit. So because this output of the op amp cannot swing more than minus v set, so this simple acting as a normal RC circuit. This capacitor will short circuit at t is equal to 0 only, because of the high frequency signals, high frequency components. So we can say that there is a fixed amount of current is flowing IC at t is equal to 0 itself. This IC will be, if I apply a KVL, this IC will be V in plus V sat divided by R. So at t is equal to 0 itself, VC short circuited, so 0 volt, and IC is suddenly went to some current. This will be V in plus V sat divided by R, this amount of current. And what happened, V out went to minus V sat. This is minus V sat. So it will, then what will happen? So because this is RC, capacitor starts charging exponentially, and it will go to V in. Okay, V in volt. Okay, then in the same way, IC capacitor current will slowly come exponentially decrease and become to 0 ampere when capacitor reaches to V in volt. So when capacitor reaches to V in volt, at that time what will happen is, this circuit will come again into negative feedback system. Why? Because when this capacitor comes to charges to V in volt, so this voltage can be 0 volt, this voltage can be 0 volt, because this output cannot, don't need to swing to some uh, beyond minus V sat. Okay, it's like it cannot, don't need to go to negative rails. Why? because you have applied a fixed DC volt. Okay, so this voltage capacitor is fully charged, so there is no current flowing through this circuit, so that it again regains the negative feedback functionality. So at till uh, reaches to V in, at when it reaches to when capacitor reaches to V in, what will happen? The current flowing through this circuit, this capacitor is 0 ampere, because so this is like at this, when capacitor charges to uh, V in, this will become like this simple capacitor, this is V in. So this is acting as a open circuit. Once it charges to full V in, this acts as a open circuit, so current flowing through this is 0 ampere. Because this current is 0 ampere, so this node voltage is 0 volt, because this is positive terminal is shorted to ground, 0 volt. This is also 0 volt, because there is no current flowing through this capacitor. Current flowing through the R is also 0, and V out will be uh, V out is equal to I into R minus I into R. I is equal to 0, so V out also will be 0 volt. So when capacitor charges to V in, then it comes to negative feedback, and this voltage, V output voltage, will become 0 volt. So it, V out will look like this. So first it will go to minus V sat and stays there till capacitor charges to V in, then it again V out will become 0 volt. So previously, if I don't have plus vsat and minus vsat, at t is equal to 0 itself, it was going to some minus delta t into r, because it cannot in practical op amp it cannot swing till minus delta of t, that means impulse voltage. So that's why this square is coming here.